So we have seen how markets function, right? And especially how the price system determines how much each consumer will buy, how much each firm will produce and sell. So the market mechanism is one way to allocate scarce resources in society. Okay, if you're looking at the market for wheat, let's say, wheat requires labor and land and other things. Now, those other resources could also be devoted towards producing more rice or more vegetables, and the land could also be used for, industrial production and so on. So every resource which is being used to produce rice has alternative uses, could be used in producing other commodities. So there's a question of resource allocation, right? All the land, labor, capital, minerals, raw materials, etc. Are we allocating them in a good way to produce the various goods and services that we need? So the central question then becomes, having seen how markets allocate these resources, how markets determine how much of each good will be produced through the operation of the price system, does it do a good job? That's the question we have to ask. So there are two aspects to this, two kind of noteworthy aspects of the functioning of markets. One is market clearance. Our theory says that the prices will adjust so that demand and supply are equated, so there are no shortages and there are no excesses, right? There's no glut for certain commodities. Now, this is not true of all economic systems. I'll come to questions later. Let me cover some of this topic. So there are alternative economic systems. Of course, a stark contrast to the market system is socialism, where things are determined by some central body who makes all the decisions and gives out instructions to firms and consumers about what they should do and how much they will get. Now, when you don't, in alternative systems, when you don't allow the price system to function, a very common observation is that there are widespread shortages or excess supplies of goods. There's a joke which Ronald Reagan said in a speech about the old Soviet Union. This is before the fall of the Berlin Wall. So the joke goes something like this. In the old Soviet Union, very few people had cars. Cars was a strong luxury. Now, there's this man who had saved up some rubles so that he could afford a car. So he went to the dealership and he said, put down the money and said, okay, I want to buy a car. And they said, you'll have to wait. Come back in 10 years on this date. And so the man asks, morning or afternoon? And so the dealer is surprised. He said, 10 years from now, how does it matter, morning or afternoon? And the man said, well, I've also asked the plumber to come, and he's coming in the morning. So what that joke captures is that, in this sort of socialist system, one of the features which you saw was very big shortages, long delays, long queues to get the good that you wanted. And in the capitalist system, it's not just a matter of our theory. The common observation is that these shortages are not very common. Although at the time when I speak and say this, we are seeing shortages all around because of the pandemic. You must have read some of these reports. And as a consumer, you may have felt it, that it's difficult to get certain products. They're quite backed up, but that's a very special situation, right? That's because global supply chains have been disrupted at this point because of the pandemic, but it's not a normal state of affairs. In normal times, most of the time, you don't have excess demand or excess supply in too many markets, with some exceptions. The question to the response to that observation is that why do we care, right? Ultimately, what matters for our well-being is not whether we get the goods we need quickly, but whether we get them at all, for example, that's an important aspect. So if I have to, in one system, if I have to wait for 3 months to get some critical surgery, but I don't have to pay much, if it's affordable, if it doesn't make me bankrupt, I may prefer that to a system where I can get my surgery without delay. I can get it tomorrow, but I have to pay through my nose, and it will lead to bankruptcy and severe financial problems. I may prefer the first situation, right? So just the fact that the price system leads to market clearance very quickly is not a basis to say that it's a very good system or it promotes the welfare of individuals to the maximum possible extent. That becomes a separate and independent question. So that's the question we are going to explore today in most of today's lecture. The question of welfare, and in particular, what is our assessment of the market mechanism in terms of the welfare of individuals. Okay, so let's get to the question of welfare, right? So before that, we have to put some terminology in place. So first, let's define an allocation. Okay, so what is an allocation? Again, we are doing partial equilibrium analysis here. We're focusing on one market. The concepts that we'll talk about today have corresponding sort of versions in a general equilibrium concept. They are much more general concepts, and you will see them in the second part of the course. But right now, let's focus on a single market, like we were doing, and let's define what an allocation is. An allocation is this vector. So what is this vector? The first two, so this is a vector of vectors, right? So the first two parts, Q and X, are the quantities of the good in question, bread, let's say. So Q is the vector of quantities consumed by consumers, N of them, right? So it's an N dimensional vector. And X is the vector of quantities produced by the various firms. So Q and X are the vectors of quantities. What's T and S? T and S are monetary payments. Remember, for consumers, the other good, so to speak, is money, right? Money spent on everything else. So money is the other thing which is at play over here. So T and S are vectors of monetary payments. TI is a payment that has been asked of consumers, and SJ is an amount of money given to the firm. Okay. Now, the way to think about it is that if you have to ask the question that do markets do a good job, we have to ask whether an alternative system would have done a better job. So the way that we carry out that thought experiment is that we assume at the beginning of a welfare analysis that there is a social planner, a benevolent social planner who cares about the various individuals involved. And that social planner is all powerful. The social planner can entirely decide on this allocation that we have just defined over here. Okay, so for now, let's shut down markets. Let's move to a system where there's a social planner, and the social planner will tell each consumer how much bread they will receive and get to consume, and how much money they have to part with. And similarly, the planner will go to each firm and tell them how much to produce, and the firms have no option but to do so. And the social planner also makes monetary payments to these firms. Now, of course, this is not, I mean, we are not, yes, we are not advocating such benevolent dictators, but this is a thought experiment, which is a way of getting at the question, is there a better alternative to markets? Or at least, is there a better allocation compared to what the markets bring about? Okay, Tanu?
Sir, can you repeat what's S in here?
SJ is an amount of money which the planner gives to firm J.
Okay, sir, thank you.
And XJ is an amount of bread which the planner asks firm J to produce.
Yeah, the supply.
Of course, this social planner, we want the social planner to operate within the resource constraints of the economy, right? We can change the economic system, but that doesn't change the amount of land available to us, the amount of manpower available to us. So resource constraints have to be respected by every economic system that we want to think about or bring about. So what are the resource constraints of the planner then? Well, first of all, there's this first equation which says the sum of all the quantities consumed by consumers should add up to the same as the total production, right? There's no manna from heaven. Bread doesn't fall from the sky. The total amount of bread available is what the various bakeries have been asked to produce, right? There's nothing outside that. Natural thing to impose. So that's the resource constraint as far as the produced good, namely bread, is concerned. The second line, the second equation, is the constraint that the total amount of money also has to add up, right? That means the total money taken from consumers, the sum of the TIs, should be the same as the total money given to the various firms, the sum of the SJs. Okay, so now that we have sketched what the resource constraints are under which the planner has to operate, let's turn to the question of what does the planner want to achieve. So the planner has to be given some objective before we can proceed further and say what the planner would do. So let's postulate that the planner has a social welfare function. So the planner's welfare function, which the planner will want to maximize, is a function of the vector of utilities, overall utilities, not just utility from bread consumption, but the total utility from consuming bread and money on other goods. So that V, not the U, the V. So this is the vector of utilities for the various consumers, and pi is another vector, is the vector of profits of the various firms. So essentially what we are saying is that the planner cares about each consumer's utility and each firm's profit. Each of those items are something desirable to the planner, but of course there are trade-offs involved, right? If you want to give more utility to some consumer, you may have to either hurt other consumers by taking away some bread from them, or you may have to hurt other firms by taking away something from them or asking them to produce more at cost. So this is a function, the least we can, if we want the planner to be benevolent, each of these arguments should contribute positively to the social welfare function, right? It should be increasing in each of these elements. Now, let's start with a special case of utilitarianism. So we'll start by assuming that the planner wants to maximize the sum of utilities and profits. And remember, utilities are also measured in monetary terms, quasi-linear in our money metric utility framework. So these are all in the same currency, so they can be added up. For the moment, let's suspend the question of whether this is a reasonable welfare function to postulate. Utilitarianism is a branch of ethical philosophy, which goes back to philosophers like Jeremy Bentham and John Stuart Mill, who made a case for a certain way of weighing the interests of different people in society. They said, the objective should be to promote the greatest good for the greatest number, which in somewhat more mathematical terms can be expressed in this way. Okay, so for now, let's accept utilitarianism as the objective of the planner. What kind of allocation will a utilitarian planner choose is the question. And then the second part of that question will be, how does that compare with the allocation that a market would have brought about? Okay, so the questions are very well defined. Now, let's try to solve the utilitarian planner's problem. It's defined on the previous slide. Maximize this welfare function subject to the two resource constraints. One is the good constraint or bread constraint, and the other is a monetary constraint. So this is the planner's problem. These are the consumer utilities, these are the firm profits in a situation where the planner is involved. How do we solve this problem? Previously, when a constraint optimization like this came up, we managed to solve it through substitution, right? We substituted the constraint into the objective function and it became an unconstrained problem. So let's try that trick, and the trick will work to some degree. Look at the last constraint, the money constraint, okay? And now if you look carefully at the objective function, there's a minus summation of Ti from the first part and a plus summation of Sj, and those two, the constraint says, have to be equal. Whatever allocation you choose, that equality has to be respected. So one thing we can do is just throw out this constraint and cancel out all the Ti's and the Sj's from the objective function. We have done that substitution. So what do we get then? We get a simpler problem where this is what the planner wants to maximize, subject to just a single constraint, which is the constraint of bread. Now, so the problem reduces to this form. Now, can we go further? Sakshi, what's your question?
So I did not understand why we simplified it by removing the price or the monetary constraints. How did we go from the previous slide to this slide? I didn't understand that. Okay,
so we are considering an alternative to the market. Okay, and an all-embracing way of considering other systems is to abstract from whether it's socialism or a mixed economy or this or that, and instead to postulate an all-powerful social planner who takes away everybody's freedom of choice and just tells people what to do. He tells every consumer how much bread he will get and how much money he has to pay out of his wallet. Tells every firm how much bread they have to produce and how much money they will get. All right. So we are considering an alternative. So the prices have become irrelevant over here because we are not studying the market anymore. We are studying a planner who has complete power to dictate to everyone how much bread they have to make or consume and how much money they have to give up or get. Okay, so that's why prices have gone away. And that's why we are dealing with total payments in monetary terms.
Right. So is it all right if I say that they're no longer choice variables for the market because they've been given by the planner?
Yes, that's right.
All right. Thank you, sir.
The planner's situation by definition is one where all economic agents have been robbed of their choices. The planner dictates every detail of all economic transactions and activities. Yes. So that's why, first of all, the price isn't there. And secondly, all these magnitudes, QI, TI, SJ, XJ, they will be determined by the planner, not by individual agents. Okay, so now we are arrived at this form of the planner's problem. So we have achieved some simplification, but we are still left with a constraint. And now we cannot get rid of this constraint because although the linear sum of Q's have to add up to the linear sum of X's, notice that Q's and X's are put inside functions which are not linear themselves in the objective function, right? So there's no easy cancellation that we can do. So now it's an irreducibly complex problem of constraint optimization. Okay, now you must have studied, most of you should be familiar with the Lagrangian method. So in a nutshell, what does the Lagrangian method say? Well, this is something that we are borrowing off the shelf from mathematics. Lagrange, the great mathematician, proved that if you have a problem like this, there's a function you're trying to maximize, which is called the objective function, subject to some constraints, equality constraints. One way to write the equality constraint is to write summation of Qi minus summation of Xj equal to 0. We can always write it in a form so that on the right-hand side, there's 0. On the left-hand side, there's everything else. And so what's on the left-hand side is called the constraint function. So the constraints can always be written as the constraint function equal to 0. In this case, we'll write sum of Qi's minus sum of Xj's equal to 0. So what Lagrange proved mathematically, rigorously, generally, is that you can set up a new function, which is called the Lagrangian function. It takes the following form. You take the objective function first, the function which you're trying to maximize, and you plus some weighted sum of the various constraint functions. In this problem, there's only a single constraint function because there's a single constraint. You may have other problems, there's multiple equality constraints. In that case, you have multiple constraint functions. So the second part of the Lagrangian the Lagrangian function is some weighted sum of these constraint functions. And the weights are introduced as new variables, artificial variables introduced into the problem. They're called Lagrangian multipliers. And they're usually denoted by lambdas. So if you have three constraint functions, you'll have a lambda 1, a lambda 2, and a lambda 3. Here things are simple. We have a single constraint function. So there's a single Lagrangian multiplier, lambda. And then what Lagrange goes on to say is that, roughly speaking, trying to solve a constrained optimization problem like this is almost equivalent to trying to maximize or find some sort of inflection point of this Lagrangian function. So the Lagrangian method essentially, again, slightly roughly speaking, boils down a constrained optimization problem into an unconstrained optimization problem. Okay? And essentially, the solution to the problem is obtained by setting all the first derivatives of the Lagrangian function equal to 0. I'm just rehashing what you already know, all of you, I'm presuming, but it's worth restating it. So, having set up the Lagrangian function, we'll take its derivative with respect to all the qi's, all the xj's, and finally, also the Lagrangian multiplier. We'll take all these derivatives and set all these derivatives equal to 0. That will give us a solution to the original constraint optimization problem. We are borrowing this result from mathematics. Okay, so let's see what we get when we do that. If we differentiate the Lagrangian with respect to qi, notice what we'll get. We'll get a derivative from here, right? That will be the marginal utility of consumer I, or ui prime. And where does qi appear elsewhere? It appears in the last linear part over here. And there it's linear with a coefficient of minus lambda. So del L del qi equal to 0 means this marginal utility minus lambda equal to 0. And so this marginal utility equals lambda. Now, if you differentiate with respect to xj, you get something corresponding. You get a minus c prime j from here, negative of the marginal cost of firm j, and you get a plus lambda from this part. Okay, so that is equal to 0, which again means that this marginal cost of firm j should be equal to lambda in the solution to the Planner's problem. So each marginal utility of each consumer has to be equated to lambda, and each marginal cost of each firm has to be also equated to lambda. So in the Planner's optimal allocation, whatever that is, there's a very important condition which will hold, which is that each consumer's marginal utility will be equal to each firm's marginal cost. That's the conclusion that we get. Now, let's, having arrived at a characterization of the Planner's optimal allocation, let's now think back to what conditions guided how the market allocated this thing. In particular, how the market determined how much each consumer, how much bread each consumer will consume and how much bread each bakery will make. What was the condition there? So now we are comparing the two systems, right? The first system is the market and its resultant allocation. The second is the utilitarian planner and the optimal allocation that the planner will choose. And now we're trying to compare the two, particularly in terms of the quantity of bread for each consumer and firm. Now, in the market situation, what was the optimality condition of the consumers? It was that each consumer equated his marginal utility to the market price. And each firm equated or chose up to a point where its marginal cost was equal to the market price. So in the market allocation 2, each consumer's marginal utility was equal to each firm's marginal cost. And it's very easy to show that if you have a diminishing marginal utility and increasing marginal cost, strictly diminishing marginal utility, strictly increasing in marginal cost, there's a unique vector of quantities which satisfies this property that marginal utility is equal to marginal cost, and also satisfies the resource constraint, right? So this condition uniquely identifies a vector of Q's and a vector of J's, which will arise if you leave things to the market, and will also arise, the same thing, the same quantities will also arise if we hand it over to a utilitarian planner. So that's the first glimpse, well, more than a glimpse, into an important property of markets. What we have concluded is that a utilitarian planner, at least as far as the quantities of bread is concerned, will not want to change what the market was doing. So in that sense, the market was doing something right. Okay, let me take questions. Rishi.
Good afternoon, sir. Sir, I wanted to know what would be the economic interpretation of lambda here?
I'll come to that. Okay, lambda. The lambda would be, it would be kind of the shadow price of bread. It would be the sort of, at the optimal allocation, how much is bread worth in monetary terms to these people? And then although they're not allowed to choose, if they were allowed to choose, what's the prayer? It'll be something like that. But over here in this exercise, we're just using lambda as a device, right? It has no intrinsic economic meaning. We can tease out an economic meaning at optimal solutions. Neha?
Yeah. Sir, I had a question that can we depend on this result always, since Lagrangian method has its limitations also?
What limitation of the Lagrangian method?
Like it's only for the functions that are differentiable.
Oh, yeah, sure. See, of course, throughout this exercise, since we are deriving derivative conditions, we have to assume that all of the functions involved are twice continuously differentiable. Okay. Now, you may want to quibble with that, but really, I mean, even if they're not differentiable, but they are, and even if these quantities are not on a continuum, right? They're discrete units. As long as the units are small and the functions, even though not differentiable, are continuous kind of functions. I mean, all that we are saying can also be stated using inequalities, right? The same points can be made. It's just cumbersome to write down and analyze. That's why we assume differentiability. So the main economic points and results do not really rely on the differentiability assumption. Differentiability just makes life easier for us when we are analyzing it mathematically. So don't think that differentiability is a, there are other assumptions flying around which are very, very important. For example, prices always adjust to clear market. That's a substantive assumption, yes. Or assumptions that, I don't know. For example, you could say that, just to randomly seize upon a point, that why is it important what the allocation are? People may care about the process, for example. So I may live in a country where there's a social planner who brings about a very good allocation in monetary terms, in material terms, but I really resent the fact that I don't have freedom of choice. Okay. So those are much more substantive issues. The technical issue of whether the functions are differentiable or not are not of first order importance.
Okay, thank you, sir.
Aditi?
Yes, I just want to confirm the conclusion of this FOC is that this condition gives us this unique vector of the quantity demanded and the quantity supplied, which is the
Once again, we should be very careful with terms we are choosing, right? If you're talking about the Planar solution, we are not, we can't talk about quantity demanded or supplied, right? Just, I'm being pedantic, but for a reason. Let's say the quantity is consumed by consumers and produced by firms.
Okay, sir. Yeah, quantity consumed and produced by firms, which is the market allocation as well as the utilitarian allocation as well.
That's right.
Okay, yeah.
They completely match up. They're identical.
Yes, yes. Thank you.
Shubham?
Yes, sir. I wanted to ask, in this model, the price is exogenously given because the planner is deciding the prices, right?
There's no price here. The planner is deciding. These monetary payments, TI and SJs, you shouldn't think of them as prices. First of all, they're not amounts levied per unit, first of all, but also they are not prices in the usual sense that which people choose to pay. They're just amounts which have been levied. They're more like taxes or subsidies.
So they are given outside the system, no?
No, they're not given outside the system. They're given by the planner.
Okay.
They're endogenously chosen by the planner. It's just that it's now we are not focusing on a market system. Of course, we're comparing with the market's outcome, but this analysis in itself refers to an alternative system where social planner decides everything.
Okay, sir. Thank you.
Okay, Mansi.
So I just wanted to ask, like, in this situation, the lambda will be representing basically the rate of change in the objective function, which determines the difference between the utility and the cost with respect to a constraint, right? So when we take out the first order condition and we get utility, marginal utility and the marginal cost, we equate it equal to lambda. So how can they represent a change when we change the constraint?
Your question relates to the interpretation of lambda over here?
So that lambda, I have understood according to the Lagrange definition, but I'm unable to fit it in this definition of the utility.
For now, okay, let's focus on, let me not get into too many things. For now, forget about it. Lambda is a technical device. All right. As long as this is mathematically correct, notice that lambda cancels out. So let's not worry about what lambda might mean. Like, let's just say it's a mathematical device which helps us get to this condition. And after having reached this condition, we'll forget about lambda. We'll be very ungrateful to this Lagrangian multiplier thing. After it has done its job for us, we'll leave it out. Okay. But let's focus on forgetting the lambda sitting in the middle. Okay. Let's focus on the economic meaning and significance of this equality, that if the planner chooses optimally, then every consumer's marginal utility will be equal to every firm's marginal cost. There's much more stuff to understand over there. So let's keep our focus there at the moment. Okay.
Okay, sir.
Aishwarya?
So there is a chance that the number of firms are not equal to the number of consumers. So how can we come to a one-on-one identity? So we are saying that for the marginal utility of each or one consumer is equal to the marginal cost.
What is the problem there? Let's say the planner has decided that every student in MA previous economics class will get a stipend of 10,000 rupees a month. The professor in Delhi school will also get the same amount, let's say. Many more students than professors. Can't all of these things be equal to each other? Is there a problem?
So, but they might not be. So I'm not able to, shouldn't, and where does the summation part of this go? So suppose there are two consumers.
It is very simple. So two consumers, let's say there are three consumers and two firms. Okay.
Right.
So we are saying a quantity, so the 5 quantities will have to be chosen.
Yes.
Quantity consumed by each consumer and the quantity produced by two firms. The only restriction is that the total consumption of the consumers must match the total production of the firms. And now we are saying that the planner will want to choose it in a way so that each of the 3 consumers' marginal utilities have to be equal to each other, first of all. Each of the firms' marginal costs will have to be equal to each other. And moreover, there has to be equality across these groups.
Right.
Now, you may wonder about you may wonder about existence. Is there a quantity vector which satisfies all of these conditions at the same time, namely, this condition and the resource constraint condition? And that will be a legitimate worry if that is your question. But existence can easily be shown as long as there's strictly diminishing marginal.
Negative and yes, got it, sir. Thank you.
Okay. Okay. Let me move on unless somebody has a strictly clarificatory question. Okay, I'll come back to questions and take more. Okay, so that's quite a significant result, isn't it? Now, let me ask a question now. We have talked about the Q vector and the X vector. Right, we have completely pinned it down in the planner's problem. But remember, the planner is also supposed to choose these monetary amounts, the T's and the S's, these monetary transfers. Now, nothing on this slide and this condition tells us what the optimal values of T and S are going to be. So how do we find that? Excellent answer on Q and X, full marks. But what is the optimal value of T and the optimal values of the S's?
Sir, is there an optimal amount or there could be anything, any value?
Yes. The optimum values of T and S are completely indeterminate. They can be anything. So what is go back to the planner's objective function. The reason we managed to eliminate this constraint is because the objective function was linear in the monetary amounts, not linear in the quantities, but linear in the monetary payments between consumers and firms. So this resource constraint is automatically satisfied inside the objective function. In other words, once you fix the quantities, the planner is completely indifferent to how you structure these monetary payments, satisfying the resource constraint, of course. So the planner really doesn't have a view about who should pay how much to whom. What the planner really cares about are whether the right amounts of bread are consumed and produced. And of course, that's a special feature of the quasi-linear utility that we are dealing with. For other more general utility functions, the planner would probably care about the monetary transfers too. Or for other kinds of social welfare functions, not utilitarian ones, again, the monetary payments would become significant, that it would matter who pays how much to whom, but not in this case. In other words, the utilitarian planner and with quasi-linear utility is insensitive or doesn't care about questions of distribution. After eliminating that monetary constraint, what we got, what is this? This is the sum of utilities measured in money minus the sum of costs. You can think of this as the social surplus, or to put more colloquially, this is kind of like the size of the cake that has been created. That's a funny way of putting it. You're saying you make bread to make cake, but that's a silly take on it, right? In general, whatever be the commodity, one way to think of this is that this difference is a social surplus or the size of the cake. So the utilitarian planner wants to make the collective cake as big as possible. And then the monetary payments, T, TI, and SJ, every vector of monetary payments basically decides how that cake will now be cut and who will get how big a piece. And what for the utilitarian planner in this context, how the cake will ultimately be cut up doesn't matter. What matters is the cake is as big as possible. So this is a nice feature. And now you can see, some of you were asking questions at the beginning. Now you can see why I started with this special quasi-linear utility, etc. Because I can completely separate discussions about efficiency or the size of the cake or maximizing social surplus versus questions of distribution. All right, Shishir.
Yes, sir, I have some doubts about this analogy that you gave to the cake. I just wanted to ask that all the different consumers that we have in the economy, their utility functions can be different, right? Like the functional form of the utility functions can be different.
Sure.
So the amount of quantities that will maximize basically the Q1, Q2, Q3 can be different.
Yes.
So if we say that we want to maximize the size of the cake for the consumers, so we will want to
we want to maximize the size of the cake for society as a whole.
Yes, sir.
What I'm referring to
I'm just simplifying it to just consumers for now, because it can be it can be mirrored for the producers as well. So my basic question is, if we have the specific quantities of Q1, Q2, Q3, then why are we saying that the question of distribution is out of case for this utilitarian planner? Because the utilitarian planner is also deciding the specific amounts of Q1, Q2 to give to each consumer and specific amounts of X1, X2 to produce for each seller.
The reason is that no matter how you view the interests of different agents, consumers and firms, there's this very powerful instrument, the monetary payments. Okay. Now, for example, instead of a utilitarian planner, you may have somebody who wants to do favoritism or puts more weight on certain consumers, his friends, or certain firms, his friends. In this framework, the way to confer these favors, right, is not to mess with the quantities. It's by choosing the monetary payments in an appropriate way. So if suddenly from an impartial utilitarian, the planner became, wanted to play favorites, what the planner would do is not change around the quantities of bread produced and consumed, but just ask, just take money from others and give more money to his favored entities, favored agents. So that's the way in which, questions of efficiency or size of the cake become separate from questions of distribution. The monetary payments become the instrument of distribution. The quantities become the instruments of achieving efficiency or the largest possible social surplus.
Yes, that's okay, sir. Thank you.
Okay, Ananya.
So I just had a clarification. So we just said that the distribution of T and S doesn't really matter to the outcome. So technically, that would mean that the social planner could give all the subsidy to a particular firm or tax everything from a particular consumer. But since this distribution of taxation and subsidy might in a sequential manner happen before the production and consumption process takes place, wouldn't there be some sort of limit to how much a particular consumer can be taxed? Like probably the entire summation TI amount a consumer might not have that much to pay to the social planner. So in that case, won't it mean that certain combinations of TIs might not be possible to achieve because it's simply not possible to take that much from a particular consumer?
Yes, you're right. But that would not create very deep conceptual problems. Okay. Let me just bypass that by saying the money endowments which various agents have are large enough.
Okay.
Yeah.
Thank you, sir.
You're absolutely right that, if there are limits to that, I have to worry about corner solutions when we get down to the question of distribution. As long as, no, let me put it this way. Once you have maximized this, as long as a distribution that you want to create does not run into these monetary endowment constraints, those constraints they don't have any bite.
Right. Okay. Makes sense, sir. Thank you.
So, Shubham.
Sir, just wanted to clarify in this planner doesn't care about TI and SJ because there is a quasi-linear utility, or because we are in utilitarianism?
Because of both. Because
of both.
Yeah.
And sir, if we have another, like if we have a Cobb-Douglas function for utility, then would TI and SJ matter in this system?
Of course. So the answer to your question is depends on both. Right? You drop either of those assumptions, and then the monetary payment vectors would start affecting things in a more intricate manner. Mansi?
Okay, sir. Thank you.
So, like, my question might be very basic, but just wanted to know, like, a consumer wants to maximize the utility. So he wants very high marginal utility, and a firm wants very low marginal cost. So basically, the planner is summing up the happiness and increasing the welfare of the society by putting the utility of the consumer equal to the cost of the firm, like to marginal utility to the marginal cost of the firm.
Yeah. So every time you go and make some poor bakery bake more bread, it's costly. But you can take the bread and give it to consumers, which will make them happier. And we are measuring all of those in a common currency, which is money. So as long as there's a mismatch, there's always room, right? What the planner can always do. So suppose consumer wants marginal utility is greater than consumer firm wants marginal cost. Let's say we are in a situation where we find that. Now, regardless of how much we like this consumer and how much we like this firm, one thing which I can always do as the planner is ask this firm to produce more bread, break more bread, and give it to the consumer. Okay, and so suppose it costs this firm 10 rupees, and the same loaf of bread generates 15 rupees of marginal utility for the consumer. I can also always say, okay, take 12 rupees from this guy and give it to the firm who has baked this extra bread, and that's a win-win. So as long as these marginal things don't match, I can make everyone happier, and you will see that utilitarianism in that sense is not needed for the argument. I'll come to that in the next slide. Anand.
Hello, sir. So I think I want to just I want your comment on this. So one of the takeaways of this discussion is that FOC is same either you have a social planner or a market. So the only advantage a market has is there is a price signal, and so the question of distribution can be solved. And here in the case of social planner, there is nothing like that.
No, I'll put it differently. What you just said. Okay, the market solves the question of distribution in a particular way, right? Under the market, these transfers essentially become the total payments by consumers, price times the quantity they're buying. So TI becomes P times QI, where P is the market equilibrium price, and the SJ becomes P times XJ, right? So the market, after having chosen the quantities in a way that the planner also would have chosen, solves the question of distribution in a particular way. And the planner may want to choose a different distribution by opting for different monetary payments. The utilitarian planner in this special case just doesn't care, right? But markets, it's not like the market. Yeah, so the market solves the problem of distribution, but some of us may not like that solution. That's a particular way of solving distribution.
Okay.
Again, I'll say more about that in a moment.
Okay, thank you. It's just a particular way, whether you like it or not, but there is a way.
That's right. Rishi, last question.
Sir, actually, I just wanted to know the T component that we are taking. Does it only contain the payments made for bread?
Yes, we are focusing on, we are keeping the problem very, very simple at this point. So we are focusing on bread and money, and so that's all there is in this world.
So, sir, like you said, that in the initial model and in this model, the FOC remains the same. But in the initial model, we get that the consumer is always spending all of his income, and the firm is already always keep in production maximization using all of its cost that it had. So in this case, is that bound to happen? Like,
No. In the initial model, who said the consumer is spending all his income?
Sir, on the demand curve, doesn't the demand curve only shows the optimal?
He's spending all his income, Y, on the two goods, bread and money spent on others. So he's spending Y, all his income Y, on either Q or M, which is not to say that he's spending all his income on Q.
Okay. So we are just comparing the Q models here and there.
That's right. Now, so that's it's a non-trivial observation, right? That the planner, although a very different entity, would end up producing, at least as far as bread is concerned, would choose exactly the same things. Now, you might say that, okay, this utilitarianism is a very special assumption. Okay. And there's a lot of discussion in philosophy about utilitarianism. For example, okay, in an article, Steve Landsberg said the following: should we be worried about theft? You're not at home, you've gone to work or to your class, and somebody breaks into your house and steals your TV. Is this a bad thing that has happened? If you are a utilitarian in terms of TV, you will say, well, all that matters is the total quantity of TVs available. I don't care who has these TVs. You have lost a TV, somebody else has gained a TV, so we'll just shrug. Now, of course, most of us will mind. Most of us have a deeper sense of justice, that you bought your TV with money which you earned through hard work, and somebody else just taking it doesn't seem right. So then you're not a utilitarian. You not only care about the total number of TVs, you care about who gets what, because you have a sense of merit or who's deserving of getting that, having that TV. So there are many ways in which you can move away from utilitarianism. It's not an unquestioned outlook. Now, here, let's stick to what is called consequentialist social welfare functions, meaning that, okay, all that matters is allocations. You could care about distribution in other ways. For example, a rich person has a dozen TVs in their house. They have TV in every space, in the bathroom, in the kitchen, as well as bedrooms, living rooms. And now there's another poor person who doesn't have a TV at all, and is not able to watch the exciting cricket matches. And you might want to say that, well, taking one TV from this rich person's house and putting it in the poor person's house increases social welfare, or at least I think so. So there you care about distribution in a way different from the utilitarian. Anyway, one way to capture this would be to opt for more general social welfare functions. But before that, let me talk about Pareto optimality. So when we write down something like a utilitarian social welfare function, we are actually committing to a particular stance about how to do interpersonal comparisons of utility. When we are adding up the utilities of the consumers, we are adopting a particular way of weighing your utility against mine. Okay. Now, if you want to play really safe or don't want to make a strong stance, you may want to adopt a somewhat different criterion, which is called Pareto Optimality. So what is Pareto Optimality? First of all, let's talk about Pareto improvements. You take one allocation, A, and you look at another feasible allocation, B, and suppose you find in the second allocation, nobody's worse off, and at least one person is strictly better off. Okay, this is called a Pareto improvement. So if you have an allocation which does not leave any room for a Pareto improvement, there's no way to create a Pareto improvement starting from that allocation, then that allocation is called Pareto efficient or Pareto optimal. Yes, you can put this slide just sort of defines it more carefully. Now, you may want to ask the question that in this framework that we're studying, if you look at all Pareto, okay, the utilitarian allocation and the market allocation, they match, okay? But if you want to move beyond utilitarianism, and if you ask the question, what is the comparison between the market allocation and Pareto efficient allocations? The answer to that is, at least in terms of the quantity of bread, every Pareto efficient allocation will also have to match the market. Okay, you don't have to be a utilitarian. If you just insist that the allocation be Pareto efficient, okay, then at least in terms of the quantities of bread, Qs and Xs, you cannot change what the market has done. That is a necessary condition for achieving Pareto efficiency. So let's see how we can prove that. Let me make the following claim, and I'll try to sort of, if you want to understand it, I can talk more about it later. Instead of looking at Pareto efficient allocations, let me say that, okay, let us give a more general social welfare function to the planet. Okay. Let's not insist that it has to be the sum of the utilities and the profits. It can be any increasing function. And let's say the function is what we might call quasi-concave. It's like, what is a more general form of a Planner's function is trying to maximize a general function like this with those two resource constraints. And now we cannot do any kind of cheap trick of substitution. So we have to carry both the constraints, and we have to use two Lagrangian multipliers, lambda 1 and lambda 2. So this becomes a Lagrangian. Okay. And now if you apply the Lagrangian principle that all the partial derivatives of this Lagrangian function have to be equal to 0, partial derivatives with respect to the utilities, with respect to the profit terms, with respect to all the quantities, as well as lambda 1, lambda 2, the multipliers. Then we get these two lines. If you're differentiating with respect to, let's say, QI, which is consumer I's consumption, then you have to apply chain rule, okay? Because first you have to differentiate the social welfare function with respect to consumer I's utility. So that's this W, del VI. And then you have to further differentiate the utility with respect to the quantity, which gives you this marginal utility term. And elsewhere, QI only figures here in a linear way with a minus sign and a coefficient of lambda 1. So this whole thing becomes equal to lambda 1. And similarly, when you differentiate with respect to the forms xj, then you get this term equated to lambda 1. Right. So now the extra element is that there are these two extra things sitting in front. So it's not, we don't have a straightforward equality between marginal utility for each consumer and marginal cost for each firm. They're multiplied by these two things. But those two coefficients sitting in front of them turn out to be also equal to each other. Why? Because when you differentiate with respect to when you differentiate with respect to TI, okay, you'll get a term from here. Remember, V is U minus Ti. Okay. So when you do that differentiation, you'll get this with a minus sign, and that will be equate, and that plus lambda 2 equals 0. So you get this equality. And similarly, when you differentiate with respect to Sj, you get the second part of this. And so these two things turn out to be equal to each other. So you can cancel them out from the two sides of the first equation, and you end up with that same old friendly condition that marginal utilities and costs have to be equated, even for a planner who's not necessarily utilitarian. All right. And again, we see that the planner doesn't want to change how much each person consumes and how much each firm produces. Okay, Nilavo.
Sir, could you please repeat the conditions about we considered about W, function W?
We're taking a more general W where it's increasing in all its arguments. Okay, let's so that I can draw a picture. Let me imagine there's a single consumer and a single firm. All right. So here's I'll measure utility, and here I'll measure the firm's profit. Okay. Now, depending on how you allocate things, there are various combinations of utility and profit that are possible, that are feasible. All right. And on the whole, you will get a set like this, depending on how you allocate the resources, right? All these points are feasible combinations of utility and profit in this simple world, and every point outside is infeasible. So this is what may be called the utility possibility set. All feasible combinations of utility that can be generated for these two agents. And the boundary of this set, the blue line, is sometimes called the utility possibilities frontier. Right. Utility possibility frontier. And now, if you recall the definition of Pareto efficiency that I just gave you, that means all the points on this frontier, on the boundary, are Pareto efficient. There's no way you can make one of them better off without reducing the utility or profit of the other. But if you are at a point inside, then you could go northeast and make both of them happier. Okay, so these are the Pareto efficient points. Now, the social welfare here will be a function of the single consumer's utility and the single firm's profit. Okay. Now, how do we find the optimum point for the planner? Of course, the planner doesn't want to choose a point inside this set, right? The planner will want to stay on the boundary for sure, because the planner cares about both. But the question is, which point will the planner choose? Well, what we can do is draw something you're familiar with, so I'll use the term indifference curves, meaning the locus of points which generate the same value of this function. So, or iso value function curves, if you will. Okay. So here's a set of points which give rise to the same social welfare as far as this planner is concerned. Here's another set of points which give rise to a higher value of social welfare. Here's another. Obviously, the optimum point for the planner will be the point where his the contour lines, or whatever iso welfare curves, become tangent to the utility possibility frontier. Okay. Now, of course, if these curves, the iso welfare curves, if they were concave, for example, like this, then you could have a point of tangency which is actually not a maximum social welfare, but produces the minimum social welfare. So to make this problem well behaved, what we need to assume is that the social welfare function, it doesn't have to be linear like the utilitarian's case, but its iso welfare curves should be convex shaped. So that's the answer to your question. That was the second feature which I was trying to impose, but didn't explain very clearly, right? So I want to consider all planars who have this kind of shape, the extreme case being linear, right? I will even, as a special case, allow this to be linear. And if these iso welfare curves are linear, what does that mean?
Utilitarian.
That means utilitarian. This is a utilitarian planar. Now, the other question, why am I saying that this mathematical exercise that we are doing, maximize a general social welfare function subject to resource constraints, why does it give us all Pareto efficient allocations? Well, let me again refer you to the picture. So I take a particular social welfare function, I'll get a point of tangency like this. Now I could change the social welfare function, okay? And that'll generate a different set of curves and a different point of tangency, all right? So by changing around this function and considering all functional forms, I can generate all points on this boundary as a possible tangent or a possible point of tangency. So that's why when you solve this exercise, and you use all possible social welfare functions with the right curvature, you manage to generate all the Pareto efficient points in the process. Let me take questions. Let me just wrap it up and then I'll take your questions. Right. So the point here is that markets somehow bring about efficient resource allocation. It will take us to a point on the Pareto frontier, in other words. It may not give us the kind of distribution of the social cake that we want, but that's a different issue. It will not create a situation where we can make everybody happier. There's an alternative way of doing things which will make everybody happier. So this is the term, this is the sense in which the term efficiency is used in economics, right? It's used in a very narrow and tight sense. Pareto efficiency. Efficiency doesn't mean that the world is the best possible world. Efficiency, an allocation may be efficient, but extremely unequal. Some people are poor, starving, living on the streets, dying. It'll still be Pareto efficient, okay? So don't read too much positive connotation in the word efficient, okay? And finally, so this result relates to, again, most of you have seen this, but let me nevertheless mention it quite quickly. This famous quotation by Adam Smith, right? Perhaps the most famous passage in all of economics writing. It is not from the benevolence of the butcher, the brewer, the baker that we expect our dinner, but from their regard to their self-interest. Every individual intends only his own security and his own gain, and he's led in this by an invisible hand to promote an end which was no part of his intention. By pursuing his own interest, he frequently promotes that of society more effectively than when he really intends to promote it. Okay, so this idea that we can have an economic system, namely the market system, where each person is following narrow interests, is not caring about what happens to society on the whole, but nevertheless, the functioning of markets leads us to an allocation which is good in a certain sense, in the sense of Pareto efficiency. Yes, so this is called the first fundamental theorem of welfare economics, and you'll see the general equilibrium version of it later in the second part of the course. But it's quite a remarkable intellectual argument and conclusion. Okay, I'll stop there and take questions from you. Sri Srota.
Yes, sir.
Yeah.
So this is a query regarding the example of the theft of TV that you gave in
Yes.
the utilitarian framework.
Right.
So, like if a thief steals my TV, then can I incorporate that concept of justice into the utility function? Like, if I feel that the society is not just to me, then I will not be happy. So, in that sense, my utility will be decreased. So, is it possible to incorporate that, or
yes,
like there is some limitation?
What do you want to target? Perhaps yes, you can target individual utility functions, but what you really want to amend, perhaps, if you want to bring in this consideration that the theft was not a good thing, what you want to target is the social welfare function.
Okay.
Right? Now,
but it will also affect the individual utility because
of course, right? But instead of looking at every aspect of it, let me just say that the answer to your question is affirmative, and we can see that by looking at the welfare function. Okay. Now the thing is this: even if you allow very general welfare function, not necessarily utilitarian, you are making an implicit assumption, which is a very strong assumption. And what is that assumption? Let's say we keep, even in this world where the theft is not considered good, let's keep the individual utility functions the same as before. Okay, let's not tamper with that. Nevertheless, when we say that the theft should be counted as a social loss, even though the number of TVs haven't changed, what we are saying is that the social welfare shouldn't just be considered as a fact, as a function of who has what. It's not just the allocation that matters, who has how many TVs, who has how much money, who has how much bread, but how that came about is also important. The process in which the allocation came about is important. Okay, so the view that only the final allocation matters is called consequentialism.
Okay.
Right? So when we write down a welfare function in this form, we are making a very strong implicit assumption, philosophically speaking, which is we are embracing consequentialism. And if we do worry about the theft, then this kind of consequentialist welfare function will not suffice to accommodate that concern.
Okay. But utilitarianism is also consequentialism.
Utilitarianism is a particular form of consequentialism, right? The consequent matters in a particular way when things are additive. Okay, so when we move
this is
from
more general.
That's right. When we move from utilitarianism and allowed for more, general forms of the welfare function, we were still making restrictive assumptions. We moved away from utilitarianism, but we were still sticking with consequentialism.
Okay.
And we may not want to do that, depending on Okay. All right. Sakshi.
So I just wanted to confirm a couple of things. First was that the example that is currently on screen, here all 4 variables are choice variables, X, Q, T, and S, right?
Yeah.
Right. And all in all, in today's class, we've basically done 3 different setups: the market setup, the Pareto optimal allocations, and the social planner allocations. Right?
I'll put it slightly differently. We have looked at 2 setups, the social planner setup and the market setup. But within the social planner setup, we have played around with what the social planner's objective is. And that's where the subcases like utilitarianism or more general consequentialism versus other things, that's where they come up.
Right. Thank you so much, sir. Good afternoon.
Yeah. Rishi.
Good afternoon, sir. Sir, I just wanted to know, until the time that both S and T are linear, it would always be like that there is no unique value for them.
For which? For S and T? Yes, that's right. If they're nonlinear, then typically you'll get a unique value. Typically.
So if you get T in a form of demand, the quantities taken by the consumers, and S in the form of the quantity sold by the producer, then we may get a unique value for them as well.
Yes, when you look at the market, you end up, generically you end up getting unique values, but then the market operates in a particular way. When you look at the planner's solution and S and T enter in a nonlinear way in the welfare function, right, as like this general welfare function, then again, S and T will matter. It will not be the same as what the market does, only the quantities will be the same, right? Q and X's will be the same as what the market does. For a general social planner who cares about S and T in a nonlinear way, they'll choose, some optimal values of S and T. You have other first order conditions to describe that. And in general, it won't be the same as what the market has done.
Thank you, sir.
Yeah, but what you're asking, I think, let me wrap up my answer to your question by saying that if you look at this general case, which I was just discussing, that tells us that a planner may want to interfere in the market and want to change things, but what he'll want to change, if anything at all, would be the monetary payments, not the physical allocations of the code, right? That point that, the physical quantities of bread for consumers and firms is the same as the market allocation. That point is very general. Okay, so or to put differently, and finally, the reason for the planner to intervene in this market would be to affect the distribution, not to improve efficiency or take us to a more Pareto efficient point.
Okay, sir. Thank you, sir.
Yeah. Stuti.
Good afternoon, sir.
Good afternoon.
Sir, can you move back to the utility frontier figure?
Yeah.
Yes, sir. Sir, so in this case, if the planner is following, if the planner is utilitarian, right? So in that case, ISO welfare function will be straight lines, right?
That's right.
So, sir, his ISO welfare function will be higher at a point where the allocation is more equitable on this utility frontier, right?
Well, not necessarily. I mean, it depends.
Sir, because just like these convex ISO welfare function, if our ISO welfare function are linear, it will be higher somewhere where the allocation is more equitable, like somewhere in the middle of utility frontier.
Okay, it'll be somewhere.
So, sir, doesn't that mean that even that person will be more concerned about equitable allocation?
The utilitarian, you mean? Yeah.
Yes, sir. Yes.
Okay. So you're right. You've caught me up on a little bit of inconvenience because the way I've drawn the picture is for a much more general case, right? Where you don't necessarily have quasi-linear utility. Now, if you have quasi-linear utility, your utility function possibilities frontier ends up being a straight line.
Straight line, yeah. Okay.
And that's why, now, if it's a straight line and you have a general welfare function with concave ISO welfare curves, then you have a well-defined point of tendency.
Yeah.
Right? But if you're a utilitarian, then the ISO welfare curves are also straight lines, and that's why it coincides with
every point.
And you don't care, right? The picture I've drawn allows for even non-quasi-linear utility.
Okay. Thank you, sir.
Yeah.